6.2, question 5. So here's our random variable x. Let it be the red blood cell count, RBCC, in millions per cubic millimeter of blood. Okay. For healthy females, x has approximately a normal distribution of 5.6. Okay. So 5.6. So we know it's normal. The mean here is 5.6. Now it's normal. That means what? That some blood, red blood cell counts will be low, some will be high, but mostly they'll be kind of distributed right here in the middle. So we have a mean of, a mean of 5.6 and a standard deviation of 0.5. Part A asks us to convert the x interval, 4.5 less than x, to a z interval. I'm going to draw a picture of this. So this is A. Now I'll draw a normal curve here. The high point is 5.6. Now our x value over here is 4.5, so I'm going to put that over here. It's to the left, right? It's below 5.6, so I'm going to draw it to the left. So we're here at 4.5, and I want to be less than this, so I have all that interval right there. So I want that to be a z interval. So find the z value, find this z-score. Well, I know how to do that. I've got a converter. Converter says that z is equal to x minus mu over sigma. So my z-score is going to be x, 4.5, minus 5.6, all over sigma, which is 0.5. 4.5 minus 5.6 is negative 1.1 divided by 0.5. Well, that turns out to be, so that z comes out to negative 2.2. So our picture is showing this. I'm just going to draw the whole thing here with x's and z's. We don't need to do this every time, but the x value is, what's the mean? 5.6. Now we're over here at 4.5. And we have 4.5 is less than x. So 4.5, I'm looking at this, it says 4.5 is to the left of x. So 4.5 is to the left of x. Right? 4.5 is to the left of x. So we have changed that now to a z-score. This is 4.5. And our z-score is negative 2.2. So in our picture, we're saying that 4.5, I'll do it up here. 4.5 is to the left of x. 4.5 is to the left of x. So where are all the x's in our picture? If I draw those in our picture, 4.5 is to the left of x. All the x's must be over here. Right? That's 4.5 is less than x. Now if I convert it to a z-score, I'm now saying that negative 2.2 is less than z. So the 2.2 would be less than the z values. All the z values would be over here. So let's claim this is going to be negative 2.2. Now in part B, we want to convert the x interval, x less than 4.2, to a z interval. But it looks like it's going to be pretty much the same thing here, right? Except here we had 4.5, and now we just have 4.2. So what are we going to get? Here's our converter. Z is equal to x minus mu over sigma. So we are going to have x, which is 4.2, minus the mean, which we are given up at the top there to be 5.6, all over 0.5. Now that top turns out to be negative 1.4 over 0.5. So our z value here is negative 2.8. So now we're saying this, that if x is less than 4.2, that converts to z being less than, what did we just say? 2.8. negative 2.8. All right, so this is going to be negative 2.8. Now in part C, we want to convert this interval from 4.0 to 5.5 to a z interval. Okay, so I'm just going to write my x interval right here, and I'll make the conversions right here. Now remember, our converter is this. If I can get it to right here, our converter is z is equal to x minus mu over sigma. So let's put the x in here, and then we'll put it in here, and we'll compute. So we will get 4.0 minus 5. What was the mean here? 5.6 all over the standard deviation, 0.5. That is now less than z, because we're converting x to z's, less than, now put in the 5.5 minus 5.6 all over 0.5. So my calculator shows we are going from negative 0.1, that is less than z, which is less than negative 0.2. So just to be sure we know what's going on here, I'm going to draw two little curves here. The first one is in x. This is one in x. Now the high point here is 5.6, and we are going from 4.0 to the left to 5.5. All right, so 5.5. So we're going into this interval right here. But what we're doing is we're converting this to a z interval. So we're getting out of x's, and we're converting to z's, and z's look like this. The high point is 0, and we are going from negative 0.1 to negative 0.2. Okay, this is not the scale. That's what we're doing. We're just converting x's to z's, and we get a slightly different shaped curve, but the area, this area right here, that is exactly the same as that area. These two are equal. So we better report this before I forget about it here. It's negative 0.1 to negative 0.2. Part D asks us to convert the z interval, z less than negative 1.44, to an x interval. So now we're going backwards. Instead of converting an x interval to a z interval, we're going z to x. So I need a converter. How about this one? There's our converter, right? Z is equal to x minus mu over sigma. Now I'm going to write down just what I've got. Z is less than negative 1.44. So what if I wrote this? Z, but I know what, all right, so Z is less than negative 1.44. But I know what Z is. That's Z right there. So how about x minus mu divided by sigma? That's going to be less than negative 1.44. All right, so x minus, now we know the mu, 5.6. We know the sigma, 0.5. That's going to be less than negative 1.44. All right, a little bit of algebra here. Let's multiply by 0.5. So doing that, if I multiply by 0.5 on the left side, the 0.5s cancel. On the right side, 0.5 times negative 1.44, well, that's just half of that. So I get x minus 5.6 is now less than negative 0.72. And now I'm going to add 5.6. So we'll get x, right? They cancel out over here. X is less than, I got 4.88. All right, so there's my interval. Now, what's it asking us to round to? I didn't pay attention to that in the other problems. Round to 1 decimal place. All right, round to 1 decimal place. Well, how about then 4.9? All right, so we will take this one, right, I'm going to 1 decimal place. So x is less than 4.9. All right, so bringing it up to part D, right here, 4.9. Part E, all right, this is a z interval, negative 1.28 less than z. So we'll do the same thing that we just did in D, but with different numbers here. So we are going to get, here's our converter, z is equal to x minus mu over sigma. But now what I want is I want, here's what I want, be careful. I want 1.28 to be less than z. All right, so they're writing it just a little bit different than the way they wrote it in the last problem. Now here's my converter. So 1.28 is less than x minus mu over sigma. So 1.28 is less than x minus mu, which is 5.6 over sigma, 0.5, multiplied by 0.5. We'll get, that's just half of that. So I get 0.64 is less than x minus 5.6. So now we're going to add 5.6 to both sides. And now I'm getting this. I'm getting 6.24 is less than x. All right, now what does it say to do for rounding here? I got 6.24, part E. Round to 1 decimal place. All right, so I'm going to round to 1 decimal place. So I'm going to claim this is now 6.2 is less than x. And let's write our answer. I got a number less than x. What are they asking over here? A number less than x. So our number is 6.2. Part F. F. Does it ever end? All right, convert the z interval. I got a z interval here to an x interval. All right, I need a converter. I know what the converter is. It's z is equal to x minus mu over sigma. Now here's what I want. I'm going to write exactly this interval, and then I'll make my conversions. So this is going to be negative 2.25. That's going to be less than z, which is less than negative 1.00. Okay, I think I got it right. But now I know what this z is. Z is that right there, so I can just substitute it in. So I get negative 2.25 is less than z, which is x minus mu over sigma, which is less than negative 1.00. Let's put our numbers in now. Negative 2.25 is less than x minus the mean, 5.6, over the standard deviation, 0.5, and that is less than negative 1.00. All right, you know what to do here. Multiply by 0.5. So when I did that, I got negative 1.125. That's less than x minus 5.6, which is less than negative 0.5. Now we can solve for x just by adding that 5.6 to all three parts. So when I did that, I got 4.475 less than x less than 5.1. But now it says, what about rounding here? I got 3 decimal places here. It says just round to 1 decimal place. All right, 1 decimal place. Well, that 7's above 5, so I'm going to round that one up. This is already to 1 decimal place. So I'm going to write this as 4.5 less than x less than 5.1. So let's put it over here in our answer sheet. 4.5 less than x less than 5.1. Now in part G, down here at the bottom, finally the last one, if a female had a red blood cell count of 5.9 or higher, would that be considered unusually high? Explain, using z-values. All right, let's convert this to a z-score. So our converter is z equals x minus mu over sigma. All right, so our x is 5.9 minus the mean, which is 5.6 all over 0.5. All right, this comes out to a z-score of 0.6. Now, do you think that's unusually high? Well, if you think about the empirical rule, actually, we've got the empirical rule right up here at the top. Z is 0.6. Now, where's 0.6? There's 1. Here's 0.6. Now, this says if you go out 1 standard deviation, you've got 68% of all the data. If you go out 2 standard deviations, you've got 95%. If you go out 3 standard deviations, 99.7. All right, so what if you got a z-score? What if you got a z-score out here at 6? Okay, not the 0.6, but what if you were out here at 6? Now that is unusually high because within 3 standard deviations, you've got 99.7% of all the data. And if you're out there at 6, there's hardly anything out there. So that would be unusual. But here at 0.6, I don't think that's unusual at all. So I'm going to say no. A score of, now it's not negative, a score of 0.6 implies that this red blood cell count is normal. So I'm going to go with that.